Diane, for a very stimulating and insightful talk. Just for a second, before we go to questions, I want to bring your attention to this piece of paper that's on your table. We're very proud of this breakfast series. We think it's one of the most stimulating things we do. We want you to keep coming, and we want to know how to get more people to know about it. So if you could just give us a little information on how to keep this series successful, we'd really appreciate it. With that, I'll turn it over to Diane again for some questions.
Yes.
Lawns really don't have much greenhouse CO2 mitigation. There was a fourth choice of those three lawns. No lawn at all is concrete. You save water, you don't really have much CO2 erosion by grass. Why not just have concrete or sand or...
Yeah, so the question is, why not just remove lawns and have maybe no vegetation at all? I will say, I don't have a lot to say that's good about lawns, but for things like athletic fields, I mean, it is the ground cover you can walk on. I think we have way too much lawn. Most of the time, we don't need ground cover that can be walked on. You know, for very specific things, golf courses and athletic fields, you know, but I do think we should reduce the amount of lawn. Now, in terms of no vegetation at all, you'd have to do an assessment of the trade-offs in terms of ecosystem services that you want, versus. So for concrete, you don't get a lot of services out of concrete, right? And so you can walk on it. But for some people, if their aesthetic is one of hardscape, that may be the best choice for them. But for other people, they may say, well, if I pick something other than a lawn, maybe there are things I can get out of my yard that I want. I want food, or I want flowers, or I want habitat for butterflies, or something like that. It's a personal choice. Yes?
How bad is artificial grass?
Oh, artificial grass. Yeah, well, artificial grass is fine. It doesn't give you any of the benefits of real vegetation in terms of habitat for other species, and it doesn't have a cooling effect because it's not using any water. But other than that, as long as it's permeable, and I think almost all artificial grass is permeable, so that when it rains, the water just doesn't run off; it goes through. Then I don't see many problems with that. In the back.
But in all of this, isn't the ultimate pressure both locally and on the planet the growth in the population and the improving standard of living, so that people want more? If you're living in a hut, you don't have a lawn, but you get a steady job, you want a nicer house, you use more energy, you want a lawn so it looks nice. Isn't that the ultimate problem, really? And we showed at the beginning how planting trees is a very tiny effect. Even if you do all of these things, isn't population pressure going to outweigh all of the things we do?
Yeah, well, those are two pressures. There's the actual population growth in terms of numbers, and there's the rate of consumption, so the per capita resource use. Yeah, both of those things are going on. Now, this research doesn't speak much to the rate of population increase, but it does speak to per capita resource consumption. That's where I think this kind of research fits in. I totally agree with you. The world of 10 billion people cannot all live at a very high standard of living. We don't have enough resources, so we do have to look at ways of reducing that per capita consumption. This is supposed to fit into that sort of scheme. Yeah. All the way back.
Are there any modeling tools that could help select specific species on the site for a particular site? It would allow you to say, okay, here's the water usage, here's the CO2 emissions, here's the nitrous oxide emissions. So you can do a selection for your particular location.
Yeah, that's a really good question. There are some species selection tools out there, and they're based on the anecdotal information that we have. So I think a really great approach would be for us not to create a new tool from scratch, but to use some of the existing ones and plug in this information into those. Because right now, a lot of those, the people who make those tools, they would love to put in data on water use and greenhouse gas emissions and other things. They just don't have it. So a goal would definitely be to integrate our data into those selection tools. Yeah, and I feel bad about making fun of the garden. I love the garden book. Yeah.
So one of the things you want to do is, for example, if you have a lot of tree cover, large trees and stuff like that, you want to model the shading underneath them to select species of ground cover or something as well, right?
Yeah, there's a lot of different kinds of models. Now, for things like the cooling effect, we have very sophisticated simulation models of surface energy balance. And I should say that, those models exist, but they're physically based. I know this is the School of Physical Sciences lecture, but those models, they need to improve on their biology because they don't take into account species variability in water use. We are currently collaborating with hydrologists on exactly that issue. We want to improve those models because you can predict temperature fairly well using current models as long as the data that goes into it is appropriate. Yes?
Here in Irvine, there are a lot of complexes built by the urban company, and they planted a lot of trees.
Yeah.
And the complex, the houses are very close together, trees in between them. Some of these condos never have daylight because of the trees. Trees, of course, go up. They never have daylight. You need electrical lights all day long. Then you have mildew problems. And maybe you save on air conditioning, so I doubt it in Irvine is that important. But you need more for heating them. There is a balance here.
Yeah? No, I totally agree.
The light costs money too. You have to turn on the light all the time.
Right. So some of these effects, they operate on micro scale. Exactly where you put the trees relative to buildings becomes quite important.
Yes.
And so, there are things that can be done. I mean, for example, people advocate putting deciduous trees near your house. So in the winter, they drop their leaves, and that will help mitigate some of the problems with light and heating.
Yeah, tell that to the urban company.
Okay. Actually, we do work with them a little bit. Yeah.
I was wondering, the daycare park area is run by the city or the University of LA. Do they have any sort of moisture sensors that conserve water?
That's a very good question, whether people have those systems with the soil moisture sensors. Well, many institutions want those. UC Irvine would love to have those. Our system is very old, and the campus planning office knows all about these issues, and they just don't have the funds right now. And many cities are in that position where they really would love to upgrade to these systems. It would save them money in the long term, but they need money for that capital improvement. And so I think that's where a lot of places are right now. I know UC Irvine is right there.
Bill, you want to ask a question?
Well, no, I had to make a comment on the, being from civil engineering, I had to make a comment on the concrete concept. Of course, we know that's not a feasible alternative for several reasons. One, concrete has a huge CO2 footprint. Second of all, it minimizes any potential of recharge to groundwater. And that's in water, considering that it takes 20% of our electrical energy, is a huge thing. So although it might at first glance be an interesting concept, it really doesn't seem to get it. This holistic, what Diane is really saying is you have to look at the whole system. And you have to take into account all of the pros and the cons. And so I think concrete is something that needs to be changed.
Yes, thanks, Bill. Bill is the director of the Campus Urban Water Research Center. He knows a lot about these issues. Yes?
Well, what would you recommend replacing concrete with
Depends what your priorities are.
say for a driveway?
Oh, well, yes, so permeable, we have to start thinking about permeable pavers. It was beyond the scope of what I talked about today, but we have major issues with runoff from surfaces where there's no penetration of water. We need better penetration of water into the soil and into groundwater. There are a lot of options for paving your driveway with something that allows water to go through. Yeah.
Okay, it's 9 o'clock. Professor Pataki has generously offered to take a group back to see her lab, so if you have more questions, you might want to sign up at the registration table for the lab tour. Remind you once more to help us keep the series going by giving us a little information on the questionnaire. Help us conserve both money and the environment by leaving your name tag on the table so we can recycle those. And have a wonderful day. Thank you for coming.